This is a small locomotive at 1/150 scale with a total length of 48 millimeters. Due to its very small size, it doesn't have a motor or gears built in. Therefore, I will motorize it to make it move. To stabilize the movement, both axles are driven by worm gears. If only one axle is driven by the motor and the other axle is driven by rods, it results in jerky movement. I hollowed out the center of the chassis and incorporated gears. A worm gear is ideal for such a small locomotive because of its simple structure and ability to achieve a high gear ratio. To further stabilize low-speed operation, I increased the number of gears and enlarged the gear ratio. I thought that stabilizing the low speed, even at the sacrifice of high-speed performance, would be more suitable for this locomotive. I installed the smallest motor I could get. The motor's cross-sectional dimensions are 3 millimeters in height and 4 millimeters in width. I chose a small motor to make it less visible from the outside. It would be disappointing to see a large motor sitting in the cab. I attached a red plate called a footboard to the locomotive. I placed the DC-DC converter and inductor where they would likely be hidden inside side tanks. This is the main circuit board that controls the locomotive. I soldered surface mount devices onto a universal prototype PCB with a 1.27 millimeters pitch. In the center is a microcontroller, which analyzes signals from the remote control and controls the motor using PWM. This is the state of the board after wiring. The board is long and narrow so that it can fit inside the boiler. The circuit board fits snugly inside it. This is the state with the boiler and cab attached. A supercapacitor is installed under the cab as a measure for when the power supply from the rails is interrupted. It's complete with the smokestack and couplers attached. The operation is controlled via an infrared remote control.